Internal combustion engines. In this video, we understand what are the IC engines, EC engines, classification, IC engine parts, and principle of operation of four-stroke petrol engine. First one is the internal combustion engines. If the combustion of the fuel take place inside this engine cylinder, the engine is called internal combustion engines or simply IC engines. For example, petrol engines, diesel engines, gas engines. If the combustion of the fuel take place outside the engine cylinder, the engine is called external combustion engines or simply EC engines. For example, steam engines and steam turbines. The next part is classification of IC engines. This classification is based upon many parameters. First classification is based on the thermodynamic cycle. Based on thermodynamic cycle, first one Otto cycle, diesel cycle, dual combustion cycle. The next classification is based on the fuel used, whether it is a petrol used, diesel, biofuel or gas. Next classification is based upon the number of stroke, whether it is used the 2-stroke engine or 4-stroke. Next, the based on the ignition, spark ignition or compression ignition, based on the number of cylinder, whether it is a single cylinder or multi-cylinder. Next one is based on the engine placing, V engine, vertical engine, horizontal engine, opposite engine or radial engines. Next classification is based upon the cooling system, whether it is a air cooled engine or water cooled. Last classification is based on the application, transport, locomotive, marine, power generation, agriculture and earth moving. The next topic is parts of IC engine. The figure illustrates the principal parts of a IC engines in its simplest form. First part, cylinder. Cylinder is the heart of the engine. The cylinder, as the name indicates, is a cylindrical shaped component in which combustion of the fuel takes place. The cylinder is usually made from grey cast iron or steel alloys in order to withstand the high pressure and temperature generated inside the cylinder due to the combustion of the fuel. The second part is the piston. The piston is a cylindrical shaped component that fits perfectly inside the cylinder. The primary function of the piston includes to compress the charge. Charge means that is the fuel. In the case of petrol engine, the charge meaning is the mixture of fuel plus air. In the case of diesel engine, only the air during the compression stroke. Second function is to receive the force produced by the combustion of the fuel and to transmit this force to the crankshaft through the connecting rod. The third part is the piston rings. Towards the top portion of the piston, a few grooves are provided to accommodate the piston rings. The piston rings are the two types. First one is compression rings, second one is oil rings. Compression rings. The compression rings, at least two rings, press hard with the cylinder walls, maintaining a tight seal between the piston and the cylinder. This is required to prevent the high pressure gases from escaping into the crankcase. Second ring is oil ring. The function of the oil ring is to extract the excess lubricating oil from the cylinder walls and send it back to the oil sump through the holes provided on the piston. These holes are called oil holes. The next part is connecting rod. It connects the piston to the crankshaft to convert reciprocating motion of the piston to the rotary motion of the crankshaft. The connecting rod forms a link between the piston and the crankshaft. It's shown in the figure. The upper end of the connecting rod is connected to the piston by means of a piston pin or Gedgoin pin, while its lower end is connected to the crankshaft through the crank. The next part is crank. The crank is a lever with one of its end connected to the lower end of the connecting rod, while the other end connected to the crankshaft. The next part is crankshaft. The crankshaft transmits the power developed by the engine through the flywheel, clutches, transmission, and differential to drive the vehicle. The crankshaft is forged or cast from an alloy of steel and nickel. The next part is crankcase. The crankcase is the lower part of the cylinder block that encloses the crankshaft and provides a reservoir for the lubricating oil. Next one is flywheel. The flywheel is a large disc or a wheel mounted on the crankshaft. It absorbs the kinetic energy, and releases the energy to the crankshaft. The next part is valves. There are two valves for each cylinder, inlet valve and exhaust valve, or it is also called as outlet valve. Fresh charge or fuel mixture enters the engine cylinder through the inlet valve, while the burnt gases are discharged outside the cylinder through the exhaust valve. Both the valves are open and closed by means of cams driven by the camshaft through a timing gear or chain so that the charge enters or discharges the cylinder at the right time. The next topic is the four-stroke engines. The working cycle is completed in four different strokes of the piston or two revolutions of the crankshaft. The four different strokes are suction stroke, compression stroke, power stroke, and exhaust stroke. Four-stroke engines are commonly classified based on the type of the fuel used. Four-stroke petrol engine and four-stroke diesel engine. Next topic is the principle of working of four-stroke petrol engine. The four-stroke petrol engine works on Otto cycle, hence it is also called as Otto cycle engine. The charge used in a four-stroke petrol engine is a mixture of air plus petrol and is supplied by the carburetor is suitable proportions. The charge is ignited by the spark generated by the spark plug, and for this reason petrol engine is also called as spark ignition engines. Working suction stroke. At the beginning of the suction stroke, the piston is at the top dead center, or it is also called as TDC, and is about to move towards the BDC, means bottom dead center. At this instant, the inlet valve and the inlet valve is opened and exhaust valve is closed. The downward movement of the piston produces suction, or that is the vacuum is created inside the cylinder, due to which the pressure charge of air and petrol mixture is drawn into the cylinder through the inlet valve. When the piston reaches the BDC, the suction stroke ends and the inlet valve is closed. The suction of the air takes place at atmospheric pressure and is represented by the line 1 to 2 on the PV diagram. With this stroke, the crankshaft rotates through 180 degree or half revolution of the crankshaft. The energy required for this piston movement is taken from the battery or cranking the engine. Second stroke, compression stroke. During the compression stroke, the piston moves from BDC to TDC. Both the inlet and exhaust valve remain closed, as shown in the figure. As the piston moves upward, the air petrol mixture in the cylinder gets compressed, due to which the pressure and temperature of the mixture increases. The compression process is adiabatic in nature and is shown by the curve 2 to 3 in the PV diagram. When the piston is about to reach the TDC, the spark plug initiates a spark that ignites the air petrol mixture. Combustion of the fuel takes place at constant volume, as shown by the line 3 to 4 on the PV diagram. Since combustion of the fuel takes place at constant volume, four-stroke petrol engine are also called as the constant volume cycle engine. With this stroke, the crankshaft rotates by another 180 degree or half revolution. The energy required for this piston movement is taken from the battery or cranking the engine. Third stroke, power stroke. This stroke is also called as expansion stroke or working stroke. During this stroke, both the valves will remain closed. As the combustion of the fuel takes place, the burnt gases expand and exert a large force on the piston, causing it to move rapidly from the TDC to BDC. The force is transmitted to the crankshaft through the connecting rod. As a result, the crankshaft rotates at high speed. The crankshaft then transmits the power through clutches, gears, chain, etc. to turn the wheel of the vehicle and cause it to move. The expansion of the gases is adiabatic in nature and is shown by the curve 4 to 5 on the PV diagram. Since the actual power or work is produced by the engine in this stroke, it is also called as the power stroke or working stroke. Also, expansion of the gases occur during this stroke and hence the name expansion stroke. The last stroke is the exhaust stroke. Towards the end of the expansion stroke, the exhaust valve is opened while the inlet valve remains closed. A part of the burnt gases, due to their own expansion, escape out of the cylinder through the exhaust valve. This drop in pressure at constant volume inside the cylinder is represented by the line 5 to 2 on the PV diagram. The exhaust stroke begins when the piston starts moving from the BDC to TDC. The energy for this stroke is supplied by the flywheel, which it had absorbed in the previous stroke. As the piston moves upward, it forces the remaining burnt gases to the atmosphere through the exhaust valve. The exhaust taking place at atmospheric pressure is shown by the line 2 to 1 on the PV diagram. When the piston reaches the TDC, the exhaust valve closes and the working cycle is completed. In the next cycle, the piston starts moving from TDC to BDC. The inlet valves open, allowing the pressures to enter into the cylinder and the process continue. Thus, the four different stroke or one working cycle is completed when the crankshaft rotates through 720 degree or 2 revolution of the crankshaft.